Hello everyone. In this video, we shall solve previous year KSET questions on reactive intermediates. At least 2 to 3 questions will come from this reactive intermediates chapter. The first question is the match the following. In the list A, they have given this named reactions, and list 2 they have given the intermediates, name of the intermediates. You have to match the which reaction involves the which reactive intermediate. Hunts-Diecker reaction follows the involves the formation of free radicals. Feorovsky rearrangement follows the Carbanion. These we have discussed in the reactive intermediate chapter, so that I have taken these two first. And Simon-Smith involves the formation of carbenes, and Wagner-Merwin rearrangement involves the formation of carbocations. So A is 3, V is 4, B is 4, C is 2 free radicals, and Simon-Smith reaction involves the formation of carbocations. So option A is correct. So you should know the some of the named reactions and their intermediates. Okay, then only you can easily find out. Hunts-Diecker reaction is important, that follows the free radicals, and Feorovsky follows the carbanion formation. Simon-Smith involves the formation of carbenes, and Wagner-Merwin involves the formation of carbocations. Hence option A is correct. Let's know what are the just simply briefly you shall know what are these reactions. This is Wagner-Merwin rearrangement. This is neopentyl alcohol in the presence of acid. Here the protonation takes place. Here the protonation takes place. Here the protonation takes place. Hence, this involves the heterolytic cleavage. When the heterolytic cleavage takes place, here the generation of carbocation takes place. Hence, this is the intermediate, that is carbocation formation takes place. And this is not stable because this is primary carbocation. This is not stable. Hence, the migration of methyl group from this tertiary carbon takes place. Hence, this methyl migrate here. This is 1,2 methyl shift. This is secondary carbocation. This is stable, and then later the loss of beta hydrogen takes place to form the olefins. This is Wagner-Merwin reaction. Here you can see the formation of carbocation intermediate. This is secondary, hence it is stable carbocation. Next reaction is Feorovsky rearrangement. Here the alpha haloketones in the presence of base, we are going to get the carboxylic acid derivatives as product. This is the carbonyl group, this is ketone group, and this is alpha carbon having the halogen group, hence these are called alpha haloketones. In the presence of base picks the proton, that is acidic proton, base picks this proton, hence the electrons shifted to carbon. This is also heterolytic cleavage, the electron goes to carbon, hence the carbon gets a negative charge. This is the carbanion. So this is a carbanion, hence the Feorovsky rearrangement involves the formation of a reactive intermediate, that is carbanion, and later this will attack this carbon containing halogen, that is chlorine, and later finally we are going to get this as product, that is carboxylic acid derivative as the product. This is the Feorovsky rearrangement. This involves the carbanion as the intermediate. This is Hunts-Diecker rearrangement. Here the silver salt of carboxylic acids reacts with halogens, and you are going to get the organic halides, means alkyl halides or aryl halides as the products. This involves the formation of free radicals. Here these are the free radicals. Hence, these are the free radicals containing one odd electron. So this Hunts-Diecker rearrangement involves the formation of free radicals to form the organic halides. And this is Simon-Smith reaction. Here the cyclohexene reacts with diiodomethane in the presence of zinc copper couple. Here the zinc copper couple and diiodomethane, the reaction between this diiodomethane and zinc copper couple, you are going to get this intermediate. This is carbene intermediate. This is carbene intermediate. Later this will react with this cyclohexene. You are going to get this product. Hence the Simon-Smith reaction involves the formation of carbene as the intermediate. Hence the option A is correct. Next question is, which one of the following will not undergo SN1 or SN2 reaction? I have taken this question in the intermediates because SN1 involves the formation of carbocations as the intermediate. So where you can find the stable carbocation that will undergo SN1 reaction. If there is no formation of carbocations or it is unstable, then it will not undergo the SN1 reactions. Okay, let's look at the options. Here the structure is like this. Br is attached to this carbon. So when this reacts with catalyst, you are going to get the carbocation here. For the CH3Br, CH3 will be carbocation, and for this will be carbocation, and this here, this will be the carbocation. This is highly stable because tertiary. This is also stable. This is also less stable than this, but it can form. But this will not form because it is highly unstable, because it is non-planar. The carbocation which is at the bridged carbon, it is highly unstable and there is no formation of this type of carbocation, so that this will not undergo SN1. And also when it comes for SN2, we can form the SN2 here because less hindrance, backside attack will easily takes place. Here also takes place. The rate of the reaction here less, but you can form the product here. But there is a bulkier group is there because it is at the bridged carbon, so this will not undergo the SN2 also. Hence the option A is correct. This compound will not undergo SN1 or SN2. Next question is, which of the following reactions involve carbon free radical intermediates? They have given the option is Hunsdaker, acyloin. It is acyloin. N is, it is not M, it's N. Acyloin condensation. And third one C is Sandmeyer, and the fourth one is all the above reactions. We know that Hunsdaker reaction involves the free radicals because the silver salt of as carboxylic acid reacts with halogens, involves the formation of free radicals, and you are going to get the organic halides as the product. So this Hunsdaker reaction involves the formation of carbocations as the free radicals as the intermediate, and we have to check for acyloin condensation and Sandmeyer reaction. This is the acyloin condensation. Here the esters react with sodium and you are going to get the alpha hydroxy ketones as the products. These alpha hydroxy ketones are called as acyloins. Hence the esters react with sodium going to form the acyloins, means alpha hydroxy ketones. This reaction is called as acyloin condensation. You can find that here there is a formation of free radicals takes place, means acyloin condensation is also involves the free radical formation. And this is Sandmeyer reaction. Here the aromatic primary amines react with nitrous acid and you are going to get the aryl diazonium salts. This will react with copper chloride. Here there is a formation of free radicals takes place. That free radicals going to give the products. Here you can see that this will form. This has been formed by the primary amines. These primary amines react with NaNO2 plus HCl. You are going to get the diazonium salts. This will react with copper chloride. Here where you can see that here you can get these free radicals. These free radicals are going to give the aryl chlorides or aryl halides. So this is Sandmeyer reaction. This is also involves the formation of free radical intermediate. Hence A is also correct, B is correct, C is correct. Hence all the above reactions involves the formation of carbon free radical intermediates. Hence option D is correct. Next question is the correct order of stability of carbanions. Carbanions are electron rich centers. Hence electron rich centers. Hence when this attached with electron withdrawing group, then it will be stable. It should attach with electron withdrawing groups, then it will be stable. When it is attached with electron donating groups, it is unstable because already it is electron rich, so that we have to take the electrons from the carbon, then only it will be stable. Again, if you are attaching this with carbanion with electron donating groups, it will be less stable or unstable. Hence This is strong electron withdrawing, nitro group is strong electron withdrawing group, then the ketone, then the ester, and then this is also involved in the resonance structures. Hence 2 is having higher stability, 2 is higher stability, then 4, then 3. Options are 2 is okay, 2 here, 4, 3, and lastly 1. Hence option D is correct. Next question is same. In the list A they have given the named reactions, and list B they have given intermediates. We have to find out which reactions involves which intermediates. So Dieckmann condensation is intramolecular Claisen condensation. This is Dieckmann condensation reactions, and the ester containing molecules, are in the presence of base, the proton abstraction of proton takes place, hence the carbanion formation takes place. Their carbanion will attack the carbon of another ester, so that you are going to get this type of product. Hence here also the carbanion formation takes place. Hence Dieckmann condensation involves the formation of carbanion intermediate. Hence the Dieckmann condensation, formation of carbanion. 1 is D. Okay. Then Fidelkraft alkylation reactions. We know that Fidelkraft alkylation reactions means alkylation in the presence of AlCl3. So there is the formation of carbocations takes place. Hence 2 is C. In the Hoffman rearrangement, this is Hoffman rearrangement. Here the amides react with halogens in the presence of base. You are going to get the nitrenes. These are the nitrenes as the intermediates. Hence Hoffman rearrangement involves the formation of nitrene intermediates. Hoffman rearrangement, nitrenes. And finally the Ramer-Tiemann reaction. This is also well known named reaction. This involves the formation of carbene intermediates. This is the formulation reaction of formulation to phenols using chloroform in the presence of base. So formulation takes place to the phenols by the formation of carbene intermediate. This is the reaction. Phenols reacts with chloroform in the presence of bases. Here you can see the dichlorocarbene is the intermediate. Hence we are going to get the formulated product. Hence 1 is C. 1 is D. 2 is C. Hence option B is correct. 3 is A and 4 is carbene. Hence the option B is correct. Next question is, which of the following carbenes are electrophilic in character? They have given some carbenes and you have to find out which is electrophile. Means all we know that it is 6 electron system. Carbenes are 6 electron system, electron deficient species, and carbenes are electrophilic in character. But when you are attached this carbene with electron donating groups, then that will not be having the electrophilic character, because electron, when the electron deficiency is there, then only it can act as electrophile. Here this is electrophile because it is attached with 2 hydrogens. Here C, Br. This is also it can also act as electrophile. This can also act as electrophile. But when you consider the fourth one, the structure is like this. So this carbene having methoxy group attached to this carbon, this can easily give it is a electron donating group. Hence when it is carbon is attached with electron donating groups, it can give the electron to this carbene, so that there is a lesser electron density, there is a lesser electron deficiency. Hence this cannot act as electrophile. Hence 1, 2, 3 are correct. Option D is correct. Only 1, 2, 3 can behave as electrophiles. Next question is, this species formed when DMT protecting group is cleaved using dichloroacetic acid. DMT means dimethoxyturtyl. Dimethoxyturtyl means here the methoxy group is there, phenyl ring. Here also methoxy group. This is dimethoxy turtle. If you have Cl here, turtle chloride. This is protecting group. We use this compound to protect the oxygens or the functional groups. When this is cleaved using dichloroacetic acid, when you supply the acid here, the cleavage takes place here. The cleavage is going to it will be heterolytic cleavage. Both the electron goes to oxygen, and here we are going to get the positive charge, hence the formation of carbocation takes place. Next question is, for the formation of the following products, the possible intermediates respectively are. There are the two products. You have to find out the intermediates for the formation of this product. This you can easily find out because this is benzyne intermediate formation takes place. Benzyne will react with this furon, and this will attack here. You are going to get this product, hence benzyne. There are option A and B having benzynes. For this, nitrene reacts with this olefin or alkene. Here the formation of this product takes place, hence A involves this compound involves the formation of nitrene, and this involves the formation of benzene. Hence option B, nitrene and benzene, is correct. In the following conversion, which intermediate is involved? You know that here they have given the aniline, chloroformane in the presence of KOH in the heating condition. See, whenever the chloroform in the presence of base, here I will write CHCl3 in the presence of KOH, you are going to get CCl3, and later you are going to get CCl2 as the intermediate. This intermediate will attack here to this substrate. You are going to get this product. This is called this intermediate is carbene. Hence there is a formation of carbene intermediate in this reaction. Next one is, arrange the following carbocations in the decreasing order of stability. So here you have to find out the stability of these compounds, which is more stable and which is least stable. You have to arrange them in the decreasing order. So we know that resonance is higher prepared than the hyperconjugation effect than the inductive effect. So in all these compounds there is no resonance, hence we have to concentrate only on the hyperconjugation and inductive effect. All the molecules having carbons attached to this carbocations, hence inductive effect is also same. Just we have to concentrate on this hyperconjugation effect. Here there are CH3, CH3, CH2. Hence 8 hydrogens are there. Hence 8 hyperconjugation structures will form for this compound. Here 3, 6, 7. 7 hydrogens are there. 7 alpha hydrogens are there. Hence 7 alpha hydrogens, 8 alpha hydrogens. Here 7 hyperconjugation effects. 7 hyperconjugation structures will be formed. Here 3, 3, 3. 9 hyperconjugation structures will be formed because 9 alpha hydrogens are there. Here 2, 2, 2, 6 alpha hydrogens. Hence 6 hyperconjugation structures will form. Where there is more hyperconjugation structure, that will be more stable. C is having higher hyperconjugation structure, hence it is more stable. Here I'll write C is having higher than A, than B, than D. C, A, D. So C is having higher stability than A, than B, than D. Hence A is correct order of stability. Next question is, match the following carbene, nitrene, free radical, diradical. They have given the structures for intermediates. We have to find out which is carbene, nitrene, all those things, all these free radicals. Now the carbene, this is a carbene, CCl2 carbene, this is dichlorocarbene, hence this is A is Q. Nitrene is having monovalent diradical, this is having hence B is R. Free radical, here in this molecule we have 2 radicals. Here they have not mentioned the radical. This is the C is P. This is the P is the free radical, and D, here you can see there are two radicals are there, hence D is S. AQ, this is AQ, BR, CP, DS. B is the correct answer. Next question is the reactive intermediate involved in the carbylamine and remetamine reactions are. Means you have to find out the intermediates in this carbylamine reaction and remetamine reaction. We know that remetamine reactions is formulation of phenols in presence of chloroformine base. Hence carbylamine involves the carbene. So this answer is wrong because it is carbanion. This is also wrong. This is also. So carbylamine is also involves the formation of carbene intermediate. Hence option B is correct. That is only carbene intermediate formation takes place in both the reactions. The next one is arrange the following carbocations in the decreasing order of stability. Again, there is no resonance. There is no resonance. Hence, we have to find out only the hyperconjugation structures. Here, you can find 8 hyperconjugation structures because 8 alpha hydrogens. Here 9 hydrogens. Here 7 hydrogens. Here 6 hydrogens. Hence, here the option 3 is having more alpha hydrogens. Hence, it can give more hyperconjugation structures. Hence 3 is having higher stability than 1, than 2, than 4. 3, 1, 2, 4. 3, 1, 2, 4. Option B is correct. Which of the following orders is correct for the stability of these carbocations? So you have to find out the order of stability of these carbocations. In 1 and 2 there is a resonance because of the pair of electrons on the oxygen. But here there is no resonance, but here there is a minus I effect. Hence out of these two, this will be least stable. Out of 3, or among 3, the 3 will be least stable. 3 will be least stable. 3 will be least stable. Among 1 and 2, oxygen is having more electronegativity, so that these electrons cannot easily involve in the conjugation when you compare with nitrogen electrons. These are less tightly attached with nitrogen, so that these two pair free electrons on the nitrogen easily involve in the conjugation, so that 2 will be more stable than 1. 2 is higher stable than 1. 2 is higher stability than 1 than 3. Option 3 is correct. The next one, which of the following orders is correct for the stability of these carbanions? We know that the carbanions are electron recenters. Again, this is also involves the conjugation. This is also involves in the conjugation. This is also involves in the conjugation, but due to this, it is anti-aromatic. It is anti-aromatic. Due to this, it is aromatic. Due to the presence of carbanion, due to the presence of this electrons, this is aromatic. Hence, it is highly stable than this. It is least stable. So 3 is highly stable than 2, than 1. 1 is because it is due to the presence of this carbanion. It is anti-aromatic. It will be anti-aromatic. Hence, it is less stable. Then there is a conjugation. It is more stable than this, and this is more stable than this because due to the presence of this, it is getting the aromaticity. Hence 3 to 1. 3 to 1. Option 2 is correct. Then which of the following carbenes is more stable? The CH2, the structure of, this is the structure of singlet carbene, and this is the structure of triplet carbene. This is triplet and this is singlet. Due to the repulsion of these electrons in a sp2 orbital, this is less stable than this one because there is no much repulsion between the electrons, because the electrons are in the p orbitals, but electrons are in the single sp2 orbital. Hence the repulsion is more here. Hence this is less stable. This is more stable. Hence, the triplet is more stable than the singlet. Okay, these are the questions from the reactive intermediates. Thank you.